Welcome to Mr. Yang's classroom. In this lesson, we're going to be going over parabola transformations. We'll be going over vertical stretches and compresses, translating up and down, translating left and right, reflecting across the x-axis, and afterwards we'll have 3 example questions. To begin, let's take a look at our parent graph, y is equal to x squared. That's presented here on the right. So first, when we take a look at y is equal to x squared, let's plug in 0 into the x value. 0 squared is going to equal 0. And what about 1 squared? 1 times 1 is 1. What about 2 squared? 2 squared, 2 times 2 is 4. And what about 3 squared? 3 times 3 is 9. That's why we have 0, 0, 1, 1, 2, 4, as well as 3, 9. Right up here. And we know that it's going to reflect across the y-axis, so negative 1 squared will be 1, negative 2 squared would be 4, and negative 3 squared would be 9. So negative 1, 1, negative 2, 4, and negative 3, 9. That's why we have our parabola graph. We're going to be vertically stretching and compressing this graph, as well as translating it up and down, left and right, as well as reflecting it across the x-axis. First, we're going to be vertically stretching and compressing our parent graph of y is equal to x squared. So first, we'll vertically stretch this graph by a factor of 2. And to do that, we're going to place a 2 right in front of that x squared term. And then next, we're going to vertically compress by a factor of 1/2. And to do that, we're going to place a fraction right in front of that x squared term. So let's check out y is equal to 2x squared and y is equal to 1/2 x squared. When we plug in 0 into x, we'll get 0 squared is 0. 0 times 2 is 0. What about 1? 1 squared is 1. 1 times 2 is 2. 2 squared is 4. 4 times 2 is 8. And 3 squared is 9. 9 times 2 is 18. Let's check this one out. When we plug in 0 here, 0 squared is 0. 0 times 1/2 is 0. What about 1? 1 squared is 1. 1 times 1/2 is 1/2. What about 2? 2 squared is 4. 4 times 1/2 is 2. And 3 squared is 9. 9 times 1/2 is 4.5. 4.5. So let's go ahead and plot this graph. 0, 0 is right over here. 1, 2 is right over here. And 2, 8 is right over here. And it's also reflected across the y-axis. So as you can see, when we vertically stretched it by a factor of 2, it got skinnier. It got narrower. The vertical compress by a factor of 1/2. 0, 0 is right here. 1, 1/2 is right here. And 2, 2 is right here. And 3, 4.5 is right here. So as you can see, this graph, as we graphed it, it got what? Wider and wider. So as we vertically stretch it by a number that's greater and greater, it will get skinnier and skinnier, narrower and narrower. And as we vertically compress it by a factor of 1/2 or any fraction that's smaller and smaller, it will get wider and wider. Now here's our first explanation of translations. We're going to translate this graph y is equal to x squared up or down. So first let's translate it up 2. And to do that, next to the x squared term, we're just going to add a plus 2. And then to translate it down 3, next to our parent graph of x squared, we're going to put a minus 3. So let's check out those graphs. Y is equal to x squared plus 2, and y is equal to x squared minus 3. Okay? 0 plugged in, 0 squared is 0. 0 plus 2 is 2. 1 squared is 1. 1 plus 2 is 3. 2 squared is 4. 4 plus 2 is 6. And 3 squared is 9. 9 plus 2 is 11. So let's plot that. 0, 2, 0, 2, 1, 3, 1, 3, 2, 6, 2, 6, and 3, 11 is off the charts. So as you can see, this graph moved up 2 from this parent graph. Let's translate this down 3. When we plug in 0 for here, 0 squared is 0, 0 minus 3 is negative 3. 1 squared is 1, 1 minus 3 is negative 2. And when we plug in 2, 2 squared is 4, 4 minus 3 is 1, and 3 squared is 9, 9 minus 3 is 6. So 0, negative 3 is right here. 1, negative 2 is right here. 2, 1 is right here. And 3, 6, 3, 6 is right there. So as you can see, this graph moved down 3. So this is y is equal to x squared in red. In blue, we have our translated up graph. And in purple, we have our translated down 3 graph. Our next translation is going to be translating our parent graph of y is equal to x squared, left as well as right. So first, let's translate this graph left 3. So to do that, we're going to place our x term within parentheses and then add a 3. Notice how going left 3 means you're going to be adding a 3 and having that be squared. Same with the right 4, except it's going to be y is equal to putting x within the parentheses and then placing a minus 4 right here and then having that term squared. So you can see our graph of y is equal to x squared, our parent graph. And then to move it left 3, we have parentheses x plus 3, close parentheses, squared. So our blue graph was moved to the left 3. And our purple graph was moved to the right 4, right here. Finally, we'll have our last transformation, which is reflecting across the x-axis for y is equal to x squared. So to do that, we're going to place just a simple negative in front of that x squared term. So when we plug in 0 for x, 0 squared is 0, and then you put the negative 0, which is going to be still 0. When we plug in 1 for x, it's 1 squared is 1, and then that becomes negative 1. What about 2 squared? 2 squared is 4, and then that becomes negative 4. And then 3 squared becomes 9, and then negative becomes negative 9. So compared to the parent graph of y is equal to x squared, y is equal to negative x squared. It has points at 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. Okay? And this is basically the same exact graph as y is equal to x squared, just reflected across this x-axis. Now we have our first example problem. We're going to be translating this parent graph of y is equal to x squared up 2 and right 4. So let's think about how that's going to be done. So we are going to have our y is equal to, let's take a look at this right 4 first. We're going to be placing that x term within the parentheses. And do you think we're going to be doing minus 4 or plus 4? That's right. When we want to move a graph to the right 4, we're going to put minus 4. And we're going to have that term be squared. And then next, we're going to work on this up 2 portion. So to do that, we're just going to be placing a plus 2 at the end of that. So as you can see, our graph of y is equal to x squared is here in red. And in blue, we've moved our graph to the right 4 as well as up 2. For our second example, we're going to be translating our graph of y is equal to x squared down 3 as well as left 5. So let's piece that together. Y is equal to, let's first work on our left 5. So what are we going to be placing within our parentheses? It's going to be x. Would it be plus 5 or minus 5 to move this left? That's right, it's going to be plus 5 to move it left 5 units. And then how are we going to move this down 3? What do we place after here? That's right, we're going to put a minus 3. So you can see our graph being translated to the left 5 and down 3. Here's our last example. We're going to be stretching and reflecting this parent graph of y is equal to x squared. We're going to stretch it by a factor of 5 and reflect it across the x-axis. So, firstly, what do we do to reflect across the x-axis? What do we do to our x squared term? We're going to place a negative in front of that, right? So, by placing a negative, it will flip it across this x-axis. And now we're going to stretch this by a factor of 5. Now 5 is a larger number, so we can expect our graph to get narrower and narrower, not wider and wider. So we'll place a 5 right in front of this x squared as well. So our transformed graph is y is equal to negative 5x squared. And as you can see, it's a more narrower graph that has been reflected across the x-axis. Thanks for watching.